Okay, welcome to the EUniWell Open Lecture Series. My name is Miklós Kelemeyer. This is my great honor and pleasure of welcoming all of you to this open lecture. And by way of introduction, the Open Lecture Series of EUniWell is hosted by the European University for Wellbeing. And this European University of Wellbeing, in short, EUniWell, it accommodates 8 prime universities across Europe. And the Open Lecture Series is a prime event that has started about a year ago, and it has gone through numerous lectures hosted by and made by prime internationally renowned experts. Today, it is my great pleasure to introduce our speaker to you, who is no one else than Dr. Imre Varjú, who is a graduate of Semmelweis University. Earlier, he graduated as a medical student, as a medical doctor from our university, and he also earned his PhD at Semmelweis University in the subject of biochemistry and molecular biology. Later on, he had prime experience as a Fulbright Fellow at Harvard University, and then he obtained a master's diploma at Columbia University in the Mailman School of Public Health. Currently, he's a health and science communication expert and behavior strategist at a New York-based company and also at Semmelweis University, and he's also a member of the EUniWell team at Semmelweis University. Today, he will speak to us on science communication. And by way of a personal account, on a personal note, I should mention to all of you, that we have been publishing together with Imre, and our second paper has gone in for review. So I can attest that he is an excellent scientist and he's an excellent communicator. So with that, Imre, I invite you to the podium. Please give us your lecture on the role of science communication in medicine today. Please.
Dean Kellermeyer, thank you very much for the introduction. I'm very, very pleased to be here today, and I'm very excited about this presentation. And I'm also so happy to see faces, like real physical faces in the auditorium. This is an auditorium I went a lot to attend lectures and later on to hold lectures. So there's a lot of nostalgia coming through the screen. So welcome everyone. It's really, really good to see you. And I also know that there are people on the line who are joining our Zoom call from all over the world. So pleased to have you for this discussion. I'm very excited to speak with all of you. I'm gonna go ahead and share my screen very quickly. And before we actually jump into our topic today, I really wanted to give a little bit of history about why I'm so excited about this topic and why I'm so excited about the role of science communication and what science communication means to me. And the easiest way to do that is really to tell my story in a nutshell and share it with all of you. And Dean Kellermeyer was kind enough to mention quite a few pieces of this puzzle. So I'll go through these pieces quickly. And this presentation is really, really, really not about me, but I would like to demonstrate to you how you, from your position, being a medical student, or if you're on the line, being a scientist or a PhD student, or no matter where you are and what you do and how you're involved with science, you have tremendous amount of options in life. You may see one path ahead of you right now, which is either becoming a doctor, becoming a PhD, becoming something that is right in front of you, but the options are really limitless. So this story for myself starts at Semmelweis University. Both of my parents are doctors, so spoiler alert, there was a bit of a gentle pressure there for me to go to Semmelweis, but it turned out to be a great idea. From day one, I really fell in love with the details of the human body and how the molecules work together to basically sustain a whole ecosystem that is us, that is a human being. So I really fell in love with all the regulations, all the biochemical reactions. Weird, I know, but I hope you hear me out here. I was absolutely fascinated by the amount of knowledge that is out there and how the whole system works. So I stayed after I finished my MD, I stayed to do a PhD in molecular medicine, and I enjoyed that a lot. And I've always been really loving research, and I spent a lot of time in the lab. I was the lab coat, white coat lab type of person. I spent a lot of time in molecules, pipetting, and killed a lot of mice, if needed, as most of us do. So did a lot of things that I really enjoyed. But after a time, I realized that what I'm also very excited about is communicating that science. So not just doing science and creating data and organizing data and analyzing, but also presenting that data. And I went to, of course, a lot of international conferences. You need to, once you're a PhD student, you need to publish, you need to go to conferences, and those are great and fun. But what I realized after a time is what I really enjoy is how to talk about my science with people who are outside my field, with people who may not be scientists, and how can I make my research and my work beneficial for them. So really that started going on in my head, even as an MD and a PhD student at Semmelweis. And I jumped into teaching, and I taught medical students for biochemistry for over 10 years. It sounds scary to say that, but it's true. And I enjoyed every moment of it. Where this road obviously took me after a time is once I finished my PhD, I had to go look outside of my own sector and had to start exploring the world. So I went for a very short scholarship with EMBO to NIBSC, which is in the UK, with one of our collaborators, where I dug deeper into science, and we published and we made revisions, and I learned new techniques, and I developed myself further as a scientist. Then I came back and I joined a program, which was a joint program with Semmelweis University and Hungarian Academy of Sciences. I spent about a year at home, and then the big change in my life occurred when I applied for a Fulbright Scholarship. Now, the Fulbright Scholarship is one of the few exchange programs that will take you directly to the US, and I was very excited about this. This was like a dream coming true for me. I was able to enter the United States under the protection of the Fulbright Scholarship, and I was able to secure a position in one of the leading labs in my field at that time, which was at Harvard Medical School. So that's how I got to the US. And this is all science, and it was great, and I enjoyed it a lot. But during the Fulbright Scholarship, I realized that I have access to so many other different people under the Fulbright umbrella. I started talking to people from different fields, started talking to people from public health, from arts, from social sciences. And when I talked about my passion for communicating science, after a time, someone told me, one of the Fulbrighters, that you sound like a public health person. You should really do public health. And I started looking into that, and what is public health, and how could that be something that interests me? And I found out that there are actually a couple of public health programs in the US which teach health communication specifically, which is about how to break down health-based science into understandable pieces of information for broader audiences. So I took the opportunity and I applied, and I got in. And so I moved from Boston to New York at that point and started attending Columbia University, managed to get a Master of Public Health degree there with a certification in health communication. I enjoyed every moment of it. I became a certified health education specialist in the US. And then the rest really is leads us here, because once I finished this project, I joined a health communications agency in New York, where I'm still working as a director of learning strategy. So you could say that I'm a healthcare marketer. You could also say that I'm still a scientist, as Dean Kellermeyer kindly pointed out. We're still publishing, and I'm still connected to basic sciences and medical sciences. I really love to maintain that connection, and I really enjoy the process. And the third is that I joined EUniWell as a science communication lead, which was all through Semmelweis University. I guess the gist of the story here is that none of this would have happened without the starting point. You see that the story is not linear and it goes back and forth, but really my springboard for all this was Semmelweis University. So I'm a very proud Semmelweis University alum, and I can confidently say that the knowledge that you're getting here can take you to places, right? It's a level of structured thinking and the level of expertise that you gain during your years here, if you really dig into it, and if you really dig into the material, that will take you very far. So, moral of the story, start here, but then be open and explore different fields. Obviously, I'm not working as an MD. I think you can tell that, but I'm doing lots and lots of other things which are out there. So let's focus on, this is my story and how I got into science communication, but let's talk a little bit about what this really is, right? And what are the many ways of science communication? Because if you look this term up, you'll find millions of definitions online about what science communication is. To me, science communication is breaking down the language of science into understandable pieces. Now, depending on where you are and what the audience is that you're talking to, science communication can take many shapes and many forms. Sometimes scientists will need to talk to journalists, right? Sometimes those talks go well, sometimes not so well. I think we've all seen examples of either side. Sometimes you need to talk to policymakers if there's a new disease outbreak, and then you're a medical professional who needs to talk about the disease outbreak and needs to advise decision makers, legislators on how to deal with that situation. Then you will need to talk to policy people and people who speak a very different language. And then there's the general public, right, which to me is the most exciting part, because the general public, as we call it, doesn't exist. There are lots and lots of people out there from different backgrounds, different history, different levels of scientific knowledge. And if you want to speak to this general public, you're most likely going to fail. So you need to find ways in order to tailor your messaging to very specific groups of people and know who you're talking to and know what their level of scientific knowledge is and know what they're interested in order to get your message through. So I'm jumping ahead a little bit here, but that's what's the most exciting thing to me, really, is sharing scientific information with largely the general public in a way that they understand and they can act on it. Now, the added, the extra value here, of course, is science communication, as you can see online nowadays, is also good for you, right? It's good for your science. If you're a medical scientist, if you're a PhD student, and and you tweet a lot and you're active on professional sites and you're active on social media, your name will be known better. That's just how life works. Science is also driven by people. We often forget that because we think about the scientific institution as something that works like clockwork. But there are a lot of people behind those walls, and those people are eager to connect through social media. And the more visibility you have, and the more visibility your research and your thoughts have online, the more likelihood that you're going to get cited, for instance. And this has been shown in multiple studies. So there are selfish reasons, of course, why you can do science communication. I don't want to focus on that today. I really want to focus on talking to the general public and talking to people who are not scientists. And why do we need to do this? And why is it so important now more than ever to talk about science communication? There are many reasons, but I want to focus on 3 today. One is what we will call filling the gap. And we'll talk about it in a second. There's a huge gap between what medical scientists know and the general understanding of those scientific facts in the general public. There's a huge gap there that needs to be filled if we want to move forward. The second is science communication helps us understand human behavior a little bit better and helps us get in there. I don't want anyone to become a behavioral scientist after this talk. Okay, so don't worry. If some of you are already behavioral scientists, I admire you. But if not, don't worry. If you don't have to become a behavioral scientist, but you can still tap into some behavioral scientific tools to bolster your communication as a science communicator. And then the third is obviously misinformation. It's out there, it's a cliche, we hear it every single day. You open your laptop, you open your phone, you open your Twitter, you open LinkedIn, it's tons of misinformation going on all sorts of social platforms. So We as scientists need to deal with that because that's hurting us. It's hurting our science, that's hurting the implications of our science, and that's hurting society. And we can play a role there to fight that. Let's start with the gap. What's this gap? Honestly, I don't know where this image comes from. So I like to put citations and references underneath my slides, but I wouldn't be able to tell you where I found this image. I found this like 5 years ago, and I'm so happy about it. This is really what it's all about. Medical scientists, doctors, scientists are saying something, and people usually don't understand what they're saying, right? There's a huge gap there. So how do you fill that gap? And why is that important? There are two ways, obviously, to fill a gap. You can either try to fill it from this side or the other side. So if you want to take a look at the public side, how can you make people better understand what scientists are talking about? There's this concept of scientific literacy, which is how well people understand scientific concepts. It's a measurable thing. It's a skill that is out there. And we'll talk about it in a second. You have to increase that. So we somehow need to be able to increase people's science literacy skills in order to move them closer to the other side. That's task number one. It's very important, but it doesn't do the job alone. The other part of the story is teaching scientists to communicate better, because science alone is not going to fill this gap. And scientific facts alone are not changing people's minds. It's a hard pill to swallow. For me personally, as a medical scientist, also as a science communicator, it's hard to swallow, but no, science and facts are not changing people's minds by themselves. So we'll talk about these things in a second. Let's start here. Let's start with scientific literacy. So the question is, how good are people at understanding science generally? Now, the data that I'm showing here is just just general data from US, and it was done by a research group at Michigan State University, and the New York Times published this, republished this data. Basically, we can say people are not really good generally at understanding science. If you take a look at the US population, 70%, it's estimated, this is based on survey data, of course, it can be inaccurate, but I think it's around the right territory. 70% of the US can't read and understand the science section of the New York Times. They can, so read and understand means that they read and then they fill out a questionnaire and their questions on the content, and 70% of them don't meet the criteria of actually understanding what they read. And this is not a scientific paper. This is the science section of New York Times, right? Which is written for the general public. So that already tells you something. So really, if you take a look at the whole US population, and the situation is not so much better in the EU based on the few data that we have, but it's only about 1/3 of the population, or 1/4 of the population, who qualify as scientifically literate, who are able to process scientific information and understand it correctly as the scientists meant that scientific piece of data. So we're not up for a great start, right? And on the other side of the coin is that even if people try to gain scientific information and try to get access to data that we as medical scientists or scientists publish out there, and what gets online, it's usually super inaccessible. And what I mean by that is that most of the material online is just written in a reading level that is too complex for the general public to understand. You can see many studies, and I don't think it surprises many of you, but here, this example looked at in 2020 March. What this group did, they did a very basic Google search for words like SARS-CoV, COVID-19, pandemic, and just looked at the first 30 articles that came up in Google. Why the first 30? Because people are not looking beyond that, right? Generally, I mean, when was the last time you clicked to the next Google search page when you were looking for this? And they had multiple search terms and whatnot, and they summarized the data. And what they found, basically, and what you see on this graph, is that generally, what the data that is out there, the scientific information on COVID-19 that was out there, that was meant for the general public, was way too complex. You see reading levels here, median reading levels around 12th grade, 15th grade, and so on and so on. And don't worry about these words down. That's just different types of reading level analysis. This means that the reading level, which is complexity of the wording was just too high. Because if you take a look at this line is where the general public, on average in the US, reads. It's on the 7th grade reading level. That doesn't sound too high, right? And of course, where the reading level and where someone reads depends on the level of education, level of socioeconomic status. It's associated with a whole host of factors, right? But if you want to aggregate and you want to look at the average reading level in the US, it's around the 7th grade reading level. So between 7th and 12th, there are lots of jumps. So even if I were to look for scientific information, well, good luck. There's not much for me that I can understand. And then there's something even more depressing here that I wanted to share. It's depressing, but it's also very eye-opening. Another hard pill to swallow. This Nature study looked at the association between levels of scientific literacy, so how good people are able to understand scientific concepts, and the level of perceived risk of climate change. So for this study, of course, it was focusing on climate change, one very specific, scientific fact. There's a very strong consensus about in terms of the climate scientists, in terms of what the risks are and how high the climate change risks are. But of course, we know that the general public does not necessarily think the same way. Now, the hypothesis was here that if you have a higher science literacy level, if you understand science better, your perceived risk, the way you perceive the risk of climate change to the world will be higher because you understand the science better. And that's what this model says here. This is the predictive model that they built. Super simple. More scientific literacy, more perceived risk. Of course, what they found instead was the opposite. Just because someone had a higher scientific level, high science literacy level, did not mean that their perceived risk of climate change was higher, which is quite baffling. I would have at least expected like no correlation or something, but they actually found a little bit of a negative correlation there. So this really just tells you that science and understanding science alone is not going to change people's minds. And it's not just that if you talk about science, you're not going to change people's minds. It's also if they understand science, just because they understand it better, there just doesn't mean that they're going to be in consensus with scientists. So why is that? The short answer is that because people are complex, people are multidimensional, and there are millions of other factors that come at play when they're making decisions on their health, making decisions on their environmental behaviors. So this is where we need to tap into a little bit of behavioral science if we really want to understand what's going on. So that's our second topic that I wanted to touch upon very quickly. So why is it so hard to change people's behaviors? Why is that even if you're a medical professional, you're trying to ask people to cut down on smoking, or you're trying to get people to exercise, and they just won't do it. You present the facts, they understand it, they're super intelligent, they might be CEOs of a company, but they're still not going to do it for their own health's sake. And here's a more scientific version of what I was saying, that people are complex, right? This is a model that was formulated back in the 80s, actually, and this has been widely used in the world of public health and also social marketing. If you take a look at the different levels of influence on people's behaviors, there's tons of layers. You're here as an individual in the middle. You have your own skills, you have your own cognitive skills, you have your own attitudes towards health behaviors and other behaviors. You have your own little world, but that is not operating in a vacuum. There are interpersonal factors, there are community level factors that influence your behavior. If you belong to a group, if you belong to a political group, if you belong to any sort of association that thinks a certain way, you're more likely to think that way, because that's how we operate. And then there's organizational level factors. You're a part of a country, you're a part of a geographical location. There are certain rules in place where you are that you cannot forfeit. So you are bound by a lot of things. Your behavior will be influenced by lots and lots of levels of influences. But it's really important for us to understand these layers and keep digging, because, and this is specific for medical students and medical scientists. But if we take a look at the proportional contribution to let's say premature death in this example, so what are those factors that have the most power in influencing the length of human life, let's say, then you'll see that 40% is actually influenced by behavioral patterns, right? So this 40%, there's no pill that we can give, there's no surgery, there's no injection for this 40%. You can't give a person an injection and they stop smoking. I hope we can in the future, by the way, but right now it's not how it works. You can't give a pill to a person to start exercising and get healthier. And these behaviors are the most powerful things that you can do for a patient, right? Where we are in the medical field, a lot of times is very much downstream. We come after the fact. Once someone has already had their heart attack at the age of 50, right? We're coming in and we're doing magic, and we're heroes, and absolutely that has huge value. But wouldn't it be a better investment to prevent that from happening? Well, if you want to prevent those things from happening, and if you want your patients to feel the long term, then you really need to invest into behavioral thinking, because you'll need to help patients change their behaviors. And for those of you on the line who are not medical scientists, I think you can extrapolate to your field as well. So of course the problem is that no one wants to do this, right? Exercise, like going to do exercise is hard. Like every single day or every second day, it's hard. It's difficult. You're a medical student. You don't have time for this, right? Or if right now you think you have, I have a surprise for you. Just wait a few months. So no, it's not easy. It's not easy. No one wants to do this. Everyone wants the simple solution, right? So that's what this whole comic is about. No one's there to change lives. No one's signing up to change lifestyle. They're going to be like, okay, I'm just going to take a pill. I have high cholesterol. Great, give me the statins. Fantastic. It's going to get lower, and I keep doing my life the way it was. The problem is that is not going to help you live longer. So, if long story short, if really want fundamental change in how people feel, really need to tap into behavioral science. And I promise there's only one behavioral science framework that I'm going to show you today, because I do not want to get into the troubling details. But I just want to showcase that once these behavioral science frameworks are in your toolbox, at least it will help your thinking in terms of how you phrase what you're saying to a patient, how you communicate with a patient, or how you communicate your thoughts online, or how you communicate your thoughts to a journalist, if that's the case. So this is a very simple example. And we can use COVID-19 here, which is a fresh wound in everyone's mind, I think. So let's say that the message goes out. You need to get vaccinated because COVID is spreading fast. Okay, so that's the health message. It's really not good, I admit. But when you read something like that, when people read something like that, what's happening? And according to this behavioral model, there are two stages of the processing of this message. Stage number one, they look at the threat. Before people jump into solutions, and before people will take on a vaccination pill, whatever, they will think about, how bad is it for me? How bad is this situation? The perceived threat has two components. They think about what we call susceptibility, right? Can I get it? Like, am I susceptible to this disease? Am I one of the people who are likely to get it? And second of all, if I get it, is it serious enough? That's what we call severity, right? So these are the two rudimental components of how people tend to think about risk, right? And if you think about the early days of COVID, you think where admittedly lots of public health communications were across the world were failing. A lot of people were being presented messages like, well, there's an 0.3% fatality rate of COVID, or if like every 3 in 1,000 people will die of this disease, and they said, well, that's not very high, right? I mean, I think it's high, but a lot of people might have said, that's not a high risk, right? I'm young, I'm healthy, like, why is this a problem to me? So if that happens, if people feel like this threat is really not for them, they're not going to move forward. They're not going to think about the solution that you're trying to put on the table, right? So that story ends there, right? What could have been a better message is to think about, even if you don't die of COVID, there was a very high chance, a 1 in 10 chance at the beginning of getting into a hospital, and hospitals filled up very quickly and health systems collapsed. But nobody talked about, well, that's not that nobody talked about that, but that was not the center of the public health messaging. The center of the public health messaging is am I going to die of it or not? And the focus there is really, really hurting the whole healthcare system, because the focus was not right from a health systems perspective. So anyways, if you feel like the threat is not severe enough, you're going to stop there. If you're convinced that, yes, this is a serious threat and I'm susceptible to this, then you go into message processing round 2, and then you think about the solution that is presented. In this case, the solution is vaccination. So how do you think about vaccination? 2 things. One is it efficacious? Is it a good tool for me to use? And is it going to protect me against the threat? That's very important. If the answer is yes, you have a good chance of carrying through the behavior. But there's a second part that you see here, which is about self-efficacy. That's a very important thing. Self-efficacy is about my personal ability to carry out a behavior. Do I feel like I can do it? Like, I understand that the vaccine is efficacious, but I have a fear of needles. I have a fear of side effects. I have all those things, and I don't think I can do it, right? If that happens, again, we fail, and the health messaging didn't go through. So this is a very simple mental model. It's a very simple behavior model that you can use in your thinking when you're thinking about what to emphasize, because you really want to make sure that you paint a very, very good picture of the risk before you suggest solutions. And then you really have to make sure that the solution that you're suggesting is something that the patient will actually be able to do, right? So very high level, this is how you can use behavioral science frameworks in your work. And the last thing, just for one slide, I wanted to talk about the elephant in the room. The elephant in the room is there's a lot of competitive messages going out there that hurt your work. There's lots of misinformation going on. It's always been with us, right? It's not a new thing. When vaccines were introduced in the US, it was a huge wave of misinformation against the vaccines, and that was 200 or 300 years ago, right? It's just that the platform changed, and online, what you see here, and I really just want to focus on this right side, what you see here is that actually misinformation spreads faster than accurate information, right? This is how true information spreads. The depth that it's reaching on Twitter, just like how many shares and how deep it goes to Twitter, that really plateaus here after 10K minutes, while the misinformation is still spreading strong, and it's spreading faster. And this is a study that was published in Science, only looking at Twitter and only looking at comparable messages. So if you want to read more, I would love to direct you to the link. But this competition is really strong, right? The messages that are working against the medical messages and against the scientific messages are faster, right? They're usually shared more readily, and there are more algorithms sharing those shares. So that's a problem. And in the US alone, that adds up to a daily loss of somewhere around $50 to $300 million per day, just related to COVID-19 vaccination misinformation. That's a big number, right? So it hurts the economy, it hurts us, it hurts our messaging, it hurts our science. What can we do? Well, bad news, not a lot right now. We haven't figured this one out. We don't have a gold standard for how to fight misinformation. If you think that your science is going to help refute misinformation, that alone is not going to be enough. But here's a toolbox, and this is the last thing I wanted to show you. Here's a very, very simple tool that you can use in your communication, which gets you to a better place, right? Instead of just going out there and saying that what someone said was absolutely stupid, it has no scientific basis, I know better, and so on and so on, there's a sandwich that you can build. The sandwich, the first layer of the sandwich, the bread, upper bread, is facts. You say, these are the facts. Here's what we know. Here's what I know from my science. Here's what scientists tell us. Here's what the science tells us. Here's what the data shows. Then you talk about the misinformation once. You say, on the other hand, here's this piece of information that is circulating widely on the internet, and this is what it says. You repeat it once, you just say it once, because if you start getting into it and start getting hooked up on it and you repeat it multiple times, people will be more focused on the actual misinformation message, and it hurts your credibility, it hurts the strength of your message. The third, debunking. Why is that misinformation inaccurate? What can you, like, how can you show that? How can you analyze the misinformation, say, this is wrong, this is wrong, this is wrong? And then you restate the facts. And that's your debunking sandwich, basically. It's a very structured approach to debunking misinformation. So it has to be very careful, very pointed. But if you follow this, there's some good results out there in the world of public health, and this was published in Nature, this framework, and we have a good chance of utilizing this in the future for multiple messaging platforms. So lots of things we talked about, but I really want to just close as a summary by saying that the world needs you, okay? And it's, it sounds like Superman or whatnot. It really does. The world needs you more than ever. But the world needs you to be able to communicate well, to communicate your findings well, right? Because right now we're here, okay? This wave is mostly gone, or maybe it's not gone, maybe in the middle of it, but there are other waves coming on. And these other waves, that these huge problems that society will be facing, needs societal cooperation. And all of these things have to be tackled on a scientific basis. But if we stay on the level of facts and stay on the level of data, we're not going to get anywhere, because people need to be convinced, and people are very complex, and they have thoughts, and they have other things going on outside of science. So I hope you learned a couple of things today, and I hope I piqued your interest to dig deeper into some of these aspects. Without going any deeper, I really hope that we'll stay in touch. You can always find me on LinkedIn. There are not so many people with this name, I can tell you that. So you'll find me easily, and get in touch, and we can always chat. So thank you for your attention.
Thank you very much, Imre. The floor is now open for questions and comments. Until the audience thinks, may I ask one question here? So what is the objective? I mean, you raised important numbers and facts about science illiteracy. But the question is, aren't we diluting our scientific communication if you want to reach all people, even the scientifically illegible people, to understand what we mean? Is that the ultimate goal?
So that's a wonderful question. I mean, if I'm understanding the question right, is it, do we really need to reach everyone with this? Like, is that going to cause dilution of the messaging? Well, if we talk about dilution, certain medications for certain disease states require different doses, right? So sometimes a very well-timed dilution and a very well concocted dilution will be the right solution for the right problem. So I know that's a very generic answer, but I guess the big question is, do we want to see change on a societal level? Do we need to see that? And I think we usually think, why is that important, right? And I think COVID-19 and the pandemic has shown that is actually really important. In order to tackle the real issues, the huge issues that are facing our health and our society, we need to get people involved. So we need to find a solution there. And I think I also like to think about this as not just diluting a single message for the whole population. It's also being very mindful about what different segments of the population need to know. So it's also tailoring the message, not just diluting it to the general public.
Thank you very much. Now, of course, it has another side. This question has other side. Why do we want to influence the behavior of people? And is there a better way of implementing a behavioral change? Or if you want to reach a goal, like political tools or other means like law and law enforcement and so forth. I mean,
yeah, and that gets into a philosophical debate whether you want to, how do you want to change behavior? How do you want to control? Because you can coerce people. There's policies, there's legislation, and sometimes it has a place, right? Sometimes you have to force people into doing something that they don't like for the sake of the greater good. But usually legislators are very, very, very careful about when and how to apply that. So,
yes.
and I would also say that if we want to see sustained behavior change, and let's just focus on health, and let's just focus on people's well-being, I would say that you need a more fundamental change than a policy change, right? Policy can be very powerful. And if you look at smoking policies, smoking ban policies in the US, they're super effective. But I also believe that if you look at the whole span of a lifetime, there are other risk factors that we cannot regulate the same way. We cannot get people to exercise more. We cannot get people to eat better. So for those types of behavior changes, we really need to dig deeper.
Thank you very much. Maybe a last question, because there are no other questions on the. Oh, here's one. Okay. By Daniela. Excellent lecture, many thanks. Why could it be that misinformation spreads more effectively? As it may be because fake news producers are very good communicators?
Yes, very good. Oh, I love that question. I gotta say, love the question. Yes, if you look at these messages, they're very simple messages, and people are looking for the simpler solutions. Sometimes the truth and the real scientific is of course more complex, which is partially true. What partially is also true is that we scientists don't communicate simply enough. So it looks like that's the simpler solution. And there are many other things that I could say. In a case of emergency, people's cognitive abilities just drop, and people's feeling towards authority just drops. So people are looking for other ways to gain information. So that's a very, very interesting question. And actually, the Twitter study showed that it's mostly driven by people who share the information. So it's not even just Twitter bots and just algorithms amplifying the misinformation. It's actually people sharing the misinformation. People are more likely to share misinformation than the correct information. So that's a great question, and we could go on, but those are my initial thoughts.
So Imre, just on this, just stepping on this particular issue. So is there a correlation between the buying of this misinformation, I mean, susceptibility to misinformation, and science illiteracy?
So that is a great question. I think everyone thinks that there is, but the Nature study at the beginning, where they looked at the climate change risk perception, actually showed the opposite. So that was very much focused. That was very specific to climate change still. So it's really hard to extrapolate to other things. Like climate change is not something that's not really related to health behavior directly. So there might be nuances there. We should test this for multiple fields of science, but I'm hesitant to say that correlation, that I'm sure that correlation exists. I'm not sure about that anymore. I thought it did.
Great, many interesting questions. I think we have received food for further thought. Now that there are no pressing questions out there, so I want to thank you very much, Imre, for this fantastic talk. I want to thank the audience for staying with us. And with that, I close this today's open lecture of the EUniWell series. Thank you very much for coming. Thank you again, Imre. Thank you.
Thank you very much. Thanks, everyone.